Hi friends, welcome to my channel. In this video, we are going to look at problem 1541, minimum insertions to balance a parentheses string. This video, you can regard it as a continuation of the videos for problem 921 and 1963. Actually, if you compare these three videos, you could see that the codings are almost identical, but the thought processes are different. So this is due to the problem detail difference, right? So here in this one, we are given a parenthesis string S containing only open and close parentheses. So here it defines the balance of such a string. So notice that here the balance means one point to notice is that so we need to use two consecutive close parentheses to match one open one, right? So here we want to return the minimum number of insertions needed to make S balanced, right? So here the operation is that so we can insert the characters open or close at any position of the string to balance it if needed, right? So here are several examples. So if you look at the first example, you see the middle three can be matched, but we are missing a closing one, right? So this is the output one. So here, example 2, this is already a balanced one according to the definition here. So we output 0. So for the example 3, we have two closed one at the very beginning. So we need one open one to balance it. So this is the one count. And the next three actually is form a balanced one. So we don't need anything. And here we have an open one. And then we need two closed one to balance it. So the overall is 1 plus 2, that is 3. So here the constraints are the following. So we know it's very long and we need to do efficient algorithm to make it have a good time complexity. So if you compare the statement of this problem with problems 921 and 1963, you will see the two differences are the following. First, the definition of balance. So here we need to use one open and two closed to balance. The operation is that we can insert either open or closed at any position as needed. So this will be the main problem statement. So again, in parallel to the previous two problems, so we are going to do the problem with the help of stack data structure. So but we are going to give two solutions format. So one is using stack explicitly, and the other is using it implicitly, right? So this is in parallel. So the algorithm is the following. So actually, I'm going to walk through it. It's very easy to understand, but if you do it at the very beginning, it might take some time to digest. So here we are going to use two counters, or you can use one counter, one stack. So one records the number of open parentheses. The other records the number of closed parentheses. So we call it an open and an closed respectively. So we need to balance all those, right? So then we are going to do a loop. We can use for loop or while loop. For this problem, it's better to use a while loop because we need to jump 2 steps if we use two closed parentheses to match an open one. So if you meet an open, so you're going to count this one, right? Increment this one, then go to next character. Then if we meet a closed, right? So we need to check if we have open ones. And as long as we see closed ones, we need to match open ones. So if we don't have open ones, we need to one insertion for an open one, right? And then we check if the next character is also closed. If so, then we can use the two closed to balance the open one. Otherwise, so we need one insertion. So here, let's see. If we the next character is also closed, then after we balanced, we need to go to the next and next character, right? In other words, if you have a pointer or index, you need to jump 2 steps. So if not, then we need an insertion of closed parentheses in order to balance the open one. Then we go to next character, right? So after the loop, I will say while loop. I will use while loop. All the closed parentheses are matched. Then we are going to check how many open parentheses are not matched. Then the return will be the number of insertions, and then times 2 times the number of unmatched open parentheses, right? So this way you can see the temp complexity will be linear, right? So this is the basic, the logic. So now in order to explain it, so I'm going to first write a solution with explicitly using stack, and then in the next version we're going to follow the algorithm above without explicitly using a stack. So first I'm going to define a variable called insertions. So this is the needed insertions in order to match the things, and then we are going to have a stack. The stack is going to hold the open parentheses. So after the while loop, it will have a state. It will left the open parentheses that are not matched yet. So here we start in. So I start from 0. N is the length of the string. This is the routine. Then the while loop, while I is less than the length. Then first, if we see a character that is open, right, then we're going to put this into the top of the stack. And then we're going to move the pointer 1 step, right? So next, so otherwise it means that we have a close, right? A closed parentheses. So in this case, we must have a open parentheses in the stack. If not, we need to insert one, right? So then if stack, so it means that we have 1 in the stack. So we're going to do stack pop. And otherwise, if the stack is empty, so we need to increment the insertions by 1. So this if-else block means that we must match a open one, right? Open parentheses. So because we have seen a closed parentheses, it must have an open before. If not, we are going to insert that, right? So this is the meaning of this if-else block. So now, after we have this open one, so we are going to check if we can indeed match this, balance this open one, right? So if we have open one let me make it more detailed. If the stack is not empty, so it will have an open one. Now the current state is going to be something like this. We have an open one, we have a closed one. So if the stack is empty, so we are going to insert, you can imagine we can insert an open one. So still we arriving at this situation. So the close corresponds to the current index I, right? So now what we want to do is we want to check if we have next, right? If I is less than the length minus 1, then we can check si plus 1. So if this character is also closed, then what we have? So we are going to have an open one and 2 closed one. So in this case, we can balance it, right? So in this case, we are going to jump 2 steps. All the other cases, so we just have such a situation. So we have an open one and closed one, but we don't have a closed one further. Either we arrive at the end of the string or just an open one, right? Something like this, or plus end of s, right? So in this case, we need to we need to add a closed parentheses, right? Insert a closed parentheses, and in this case we are going to increment I by 1. So after this while loop, then all the closed parentheses are actually matched. Then we just need to count how many open ones left in the stack. So then due to the definition, what we want to do is we want n insertions, then plus the unmatched one, so count them, the stack. Then each unmatched open parentheses need 2 closed ones, so we need to multiply this by 2. So this is the full logic for this problem. So we can do a test. Yeah, it passes one example. Now let's look at the generic case. It passes all the cases. So now, in order to make the styles the same as the video for problem 921 and problem 1963, so we are going to write another solution, so which we implicitly using the stack. So let me copy this part. So we are going to call this one version v1. So version v1 actually it might be easier to understand at the very beginning, because for this kind of problem related to balancing parentheses or brackets, so typically the stack data structure comes into play. So now let's look at this one. So here I'm going to implicitly using stack. So here I'm going to count the left parentheses, open parentheses, and count the right parentheses. So originally 0, 0, right? And then also I introduce I and n to be 0 length of s, right? And then also I'm going to have an answer variable. This is corresponding to insertions, right? So the count left corresponds to the stack in the above problem. So now what we want to do is, well, I is less than the length, right? So if we see a open parenthesis, so this is the open one, then we are going to increment this one, count left by 1, and then we increment the index also. So this means that we meet an open parenthesis. Next, if meet a closed parenthesis. So in this case, this is the else block. So if the current count of left is greater than 0, so notice that if we meet a close, we must balance with open, right? So if we have enough open, in other words, if the current left is greater than 0, so we are going to decrement this one by 1, right? Otherwise, so we need an insertion in order to have a closed one. So so we are going to do answer increment by 1. So this if-else block is to have to match or balance a open, right? And open. If we have open, we just decrement by 1. If otherwise, we need one insertion to have a 1. So now the state is. So we have, you can imagine we have an open one, and then we have a closed one, and the close corresponds to index I, right? So the thing is that if we can match it using the next character, right? So this if I is less than n-1, in other words, we can check the next character, and then the next character is also close. So in this case, what we have actually is we have an open, we have a close at index I, open and close, and then so in other words, Si this is nothing but two close, right? So in this case, we can match the open parentheses. So in this case, we don't need increment the answer, we just increment the index by 2. Otherwise, so either we have open and close, but the I plus 1 does not exist, right? So because we can out of the string s, or si plus 1 is open, right? It's not close. So in this case, we need one insertion of close. We need insert a close. So in this case, so we are going to increment the answer by 1, and then the increment of index will be 1, right? So after this while loop, this is in parallel to this format, right? Then we're going to do answer and plus how many open parentheses left unmatched, that is the current state of count left, and then we need to increment it by 2. So this is multiplied by 2. So this is our return, right? So now let's do a test. Yeah, it passes 1. Now let's look at the generic case. Let's see where's the problem. Here. So we need to check index I plus 1. Don't be forget, because current index is I. So now let's submit. Yeah, it passes all the cases. So with that said, I guess we finished the second one without explicitly using stack. So essentially, the two formats of solutions corresponding to the same algorithm, but the second one actually is O1 in space also. Besides O1, this is O1 in space and ON in time, right? So I guess that's basically about it. Thank you.